right, good evening, everybody. And if you're on the East Coast, good morning. This is your Facebook meteorologist, Sean Bagden here, followed along with your Facebook meteorologist, Derek Centrone, looking beautiful as ever today. And we are here to talk about your, and we're here to talk about the
Pause.
tropical disturbance that is out in the Caribbean right now. And it is looking pretty ragged as we can see some very powerful south to north shear being exhibited on the system here as these thunderstorm tops are getting pulled away from the center to the north here. And we can also see some north to south shear developing off to the west of the system, which is going to help keep this area of disturbed weather from developing into anything further, at least until it gets into the Gulf of Mexico. Some models do show it intensifying into a tropical depression or low end tropical storm, but odds are looking low at this point just due to this stronger shear that it's working with here across the Gulf, off the Caribbean here, and up into the Gulf of Mexico, looking like the subtropical jet is really going to start ripping as we head into the middle and end of this week, likely inhibiting any further development of the system. Anything you want to say about this satellite imagery before we move on to the models regarding the storm, Derek?
Well, first of all, I want to say thanks for the intro. And
That was amazing.
yeah, pause. That was a little sus. um, but yeah, getting back to the storm, I would definitely agree that this is still very disorganized, and I would like to emphasize to people who have been seeing the hype posting on the internet that this is mostly going to remain disorganized. It might pick up some organization later, especially before its landfall. But it's not going to be anything more than the equivalent of a tropical storm, even if it's not called anything, even if it's not this, that, or the other thing. This will be related to a low end tropical storm for people who don't necessarily know the relationships between these systems. And the biggest threat we are going to be looking at is the rainfall from this, just because of that disorganization within the storm. We're not really going to see that really, really strong cranking wind or anything.
Yeah, absolutely. Completely agree with that. I was trying to find our CHI here, but I couldn't really find it. But I can describe what I was going to be looking at here. But basically, once we move in past the 4th, 5th, and 6th of October here, which is about the time the storm is going to be entering into the Gulf, it does appear that the Central American gyre that we've been talking about, especially when we were talking about Helene. That's how that was created. It's going to be becoming suppressed and starting to move off to the east with time and likely shutting down anything close to home as we move past the first week of October here. That being said, out in the central Atlantic, we'll likely see some quite incredible satellite imagery from some of the storms out there as the Central American gyre moves itself out into that area. But likely anything close to home, such as this system or anything that could develop on the tail end, Charlie, of the cold front that's going to be dropping into the Gulf, will likely be non-events here as we go in through time, especially after the 4th, 5th, and 6th of October here. As long as we have nothing else to say about the satellite imagery, we could move on to models, right?
Yeah, I definitely agree. I'm just looking at one thing. Something we could keep in mind later on as well that could give a little bit of a push to the system. I don't expect it to do much because the subtropical jet's just not going to allow very much, is that MJO. which could might pop the cap off of this a little bit and allow it to organize a little bit further, but it's not going to be able to maintain those tropical characteristics as it starts to move into the Gulf, but that could help consolidate things a tiny bit.
Yeah, absolutely. I would completely agree with that as well. Um, and I think what the main impact of this system is going to be as we go through time here and this enters the Gulf is going to be the flooding rains and
Hmm.
likely flash flooding once we get into Florida. From the previous model runs, we've been seeing an increase in moisture, unfortunately, and not a decrease across the area. Um, but closely looking at the models here, this is up about 30,000 feet in the atmosphere, our steering currents. But this is going to show us the trough axes, the areas of high pressure aloft, low pressure aloft. But as we move into later in the week, this is Saturday into the weekend, you can see these areas of mesolows developing here across the Gulf. These are very interesting because they can locally enhance lift, especially on the northeastern quadrant of these mesolows. And looking at the steering flow out in front of this area of out of this positively tilted trough right here, it's going to be pulling these systems off to the north and east through time. And what's to the north and east of the Gulf of Mexico and these mesolows right here? That's going to be Florida. And as these track off to the north and east, we're going to be closely watching where the northeastern quadrants of these systems track over Florida, because we could be looking at potentially significant flash flooding. I know the East Coast doesn't want to hear that again, but significant flash flooding could be possible across whatever region of Florida these heavier bands of rain set up on the northeastern quadrants of these mesolows as we track through time. And you can see they come in bands. We have this first one making landfall here across south central Florida, and also we've got another one lined up right behind that. And they just keep lining up along this stationary convergent boundary, stationary front right here, and just these mesolows continually riding across them and pummeling the same area across the Florida Peninsula here. But do you want to add anything onto those mesolows and how they're interacting with the trough access and Florida and all that?
Yeah, and something I do want to say as well is for the people who have been paying attention to a lot of the models, that is one of two modes that we've been noticing a lot with the models. The other mode is obviously the more heavily consolidated system. I think that that's going to become less and less of a trend because of that uptick in the subtropical jet that we've seen, but there is still a small chance that we could kind of have a more well-defined storm as well and kind of have it would have very similar impacts. I mean, honestly, at this point, it's kind of just semantics of what kind of system we're looking at. If we're having one of those more like strung out vorticity band systems, or if we're going to have like one with a really consolidated hybrid core with like trailing frontal systems or whatever that makes landfall and causes the same kind of impacts. Because I mean, the moisture is going to be there, the conditions are going to be there, but over time we're going to start to see a little bit more consistency in the model of which kind of mode we're looking more at as
Yeah,
well.
absolutely. Do you want to explain the 500 millibar vorticity map here? Because that explains really well what you're talking about in terms of just the strung out vorticity plumes. And then you do get those mesolows rolling in, and you start getting those more enhanced rainfall totals along those bands of vorticity, right?
Yes, exactly. And something else, maybe we should compare this model to, even though I know it's not as reliable and as accurate, the 18 Zulu, because the 18 Zulu does give a very good depiction of the alternate kind of mode, even though I don't believe it's going to be this strong. The 18 Zulu, is this the Which is
That's
this the 18?
18C, and
See how the
that's
18 Zulu has that very, very well consolidated center right in there? That would kind of be your quote unquote eye wall structure of the system in there, and that's more what you would expect out of like a more set up tropical storm or even low end hurricane versus which like I said before is unlikely given the situation, but it's still being shown in the model, so it's still worth talking about versus the Zero Zulu model, which is the last one Sean just had pulled up, which is just those plumes of vorticity coming in. And at the same time, they act very, very similarly in the sense that um, we're going to have a lot of rain. We're going to have storms just all in those boundaries. And because they're so strung out, we're not really looking at one well defined landfall in there. Every time you have one of those stronger little vorticity bands wrapping in and moving over Florida, it's just going to be another set of storms, another set of storms. And it's all just going to build on itself. And for people who live in Florida or know Florida's topography, there's not a lot of place for water to go in this. So, with all of those really, really strong bands of storms moving in, that water is just going to be pooling. It's going to be pooling in the bays. It's going to be pooling in the rivers and the lakes and eventually in the streets here. So that's not really a good situation to be in. Hopefully, the system does end up trending weaker because obviously, for people who were impacted on the West Coast by Helene, this is not an ideal situation or timing to be in.
Yeah, absolutely. And you can clearly see the stalled out boundary right here
Yep.
across North Florida here. It's pretty much stalled out right at Daytona Beach, it looks like. And anywhere south of where this stationary boundary does set up, this is still several days out right here, almost a week out, 5 days out. But where this boundary sets up, that anywhere south of that, that is going to be where that potential significant flooding can set up, especially just south of that boundary where you maximize the lift in association with that boundary and in proximity to that boundary. And as you get these vorticity waves, these meso lows interacting with that boundary, it can increase the lift on the northeast quadrant of these meso lows. And you can see weak little meso low starts rolling into the Tampa area right when it interacts with the boundary and the landmass that is Florida. It blows up right here. And actually, looking at how this interacts on the model with the mainland is actually quite interesting to us here. I'm not sure I buy the rainfall totals on this model run right here. I'm not sure why it's not working. There we go. Not sure I'm buying this because normally you would not see this cutoff band of rain over Florida. You'd likely see this in a very mountainous region. If you had a mountain right here along the coastline, it would tend to shadow this area and you'd get less rain. But there's really no reason the model should be cutting off this band of rain here across South Florida. And looking at previous model runs, it does look like this band will tend to shift slightly north, likely from the Space Coast to about Port St. Lucie from what we were seeing. This model run is a little bit further south, but it has been in the realm of Space Coast to Port St. Lucie, having this 15-inch to 2-foot band of rain right here. And closely looking at the flash flood guidance here, you can see that over the Florida Peninsula, you are really looking at about 6 to 6.5 inches of rainfall over a 24-hour period to get these reaching these flash flood guidances right here and getting the flash flooding to start where the ground really can't keep up with it anymore. And looking at the expected 24-hour precip accumulations here, you can clearly see if you extrapolate this band across, match up the color contours here with what you're seeing on the map, you are very close to that 6 to even 10 inches in a 24-hour span here, likely exceeding flash flood guidance wherever this band is able to set up, and likely seeing significant flash flooding across a large band of Florida here, where you can get that band to set up, likely between the Space Coast and Port St. Lucie. Anything else you
Something
want
I
to
want to
add
add.
on to that?
Yeah. And something else to keep in mind, if anybody else here has been in Florida these last few days, um, with that boundary that's been set up, we've been getting a lot of rain. There's no shortage of moisture, there's no shortage of rain. And these maps are usually made in perfect conditions. So I would assume that if we're just saturating the ground right now coming into this, there's not there we can't even really take into account that the ground's going to absorb any of this because I'm sure everything's already going to be saturated before this event starts. So
Mhm.
there's once again emphasizing my point I made earlier where there's nowhere for this water to go. There's not going to be anywhere for this water to go because we're expecting to get rain almost every single day over a large swath of the state. We even earlier today, big thunderstorms around the east coast of Florida.
Yeah, absolutely. There is definitely some inaccuracies in that flood map, because I believe it's about 5 days old right now. And it's showing that it would take 4 inches of rain to create a flash flood up in North Carolina near the Asheville area right now. That is 100% not the case. You could probably get a flash flood with a tenth of an inch of rain right there now. You know, so there is those discrepancies, and if we're meeting the flash flood guidance on these model runs, and we've already gotten rain over those areas that the flash flood guidance is not putting into effect, it is like even more likely that we'll see some pretty significant flash flooding across the state of Florida, likely in that 50-mile band that we were talking about there, but definitely something we have to watch the trends of as we get a little bit closer to the point in time that this band of rain is going to be impacting the state. It's likely going to be starting just before our tropical wave in the Caribbean is making its way into the Gulf of Mexico, as vorticity starts streaming up in front of that, I would imagine.
Yeah, absolutely.
Yeah, 100%. Is there anything you wanted to add on to the flooding before we move on to the next sort of flooding we might be seeing with this event?
I think that's probably it. I don't really see any other impacts as
Yeah,
of right
absolutely.
now. We can talk more about this later once we know and once these models become a little bit more consistent because obviously if this does start to take more of a traditional storm shape, we're going to have to talk about what that means. And if this continues to trend, it's going to trend a little bit more accurate and we'll be able to talk about further what this kind of event would look like and more specific numbers.
Yeah, absolutely. Completely makes sense. Um, and now we're going to have a quick look into the potential storm surge flooding threat. I know we're not really looking at a tropical storm or hurricane, which you'd traditionally see storm surge with. Um, but given how high tides are right now, and we'll actually pull up a surface wind map here and show you how to read that real quick while we're getting into this. So basically, what we're looking at right here is a plot of the surface conditions over time. Um, there we go. We're about 6 hours out. But as you can see, these are lines of constant pressure right here. And in between those lines, the closer they are together, likely the higher the wind you're going to be experiencing. This area of high pressure right here, it is anticyclonic flow around it. So you're seeing the winds circulate like this from the north down to the south. And when you see the low pressure, it's going to be circulating from the south to the north on the right side of the system.
Should we pull up 10-meter wind for this? It might make things a little easier to see.
Yeah, I can probably do that because then I don't have to explain the whole thing, right?
Yeah, exactly.
Yeah, let me see if I can find a map that shows that
Lower
real quick.
dynamics. Lower dynamics.
Yeah, that would be. There we go. 10-meter wind. Now we can see the wind barbs. That's a little bit better. But as you can see here, as our low pressure here off the coast of the Delmarva pushes away, we start to get winds pushing on the east coast of Florida, the Atlantic coast. And this is going to last for a couple of days. And the winds tend to increase over time, continually pushing onshore push of water into the coast of Florida here. Probably for 5-6 days we're looking at. And this will locally get enhanced as you get those mesolows coming through. Like here, you get,
Right there.
yeah, increase of winds right into the Space Coast. And you're seeing winds up near 30 knots or so. And that's really increasing the potential storm surge, especially along high tide. You're going to have a lot of water just sitting along the coastline, not really able to push back out, and likely not seeing a significant storm surge by any means like you would see in a hurricane, but certainly enough that homeowners along the coast that are, I'd say, within 3 feet of the sea level, I would definitely pay attention to this storm, as you could get water entering your house here, especially during the high tide cycles for about 4 to 5 days here.
Also,
Especially
along the
when,
shorelines and the bays, with this much rain coming down and that kind of almost blocking effect from that low surge, we can see a lot of contraflow into the bays there. And if you're living
Mhm.
right along there, even though a few inches of storm surge might not sound like a lot, think of it more as a wall than a surge. That 15 inches of rain is going to run off, it's going to hit that wall, and it's just going to pile, and it's just going to flood in that
Yeah,
case.
absolutely,
So,
especially the intercoastals.
mhm,
The
absolutely.
intercoastals, you get this wall of wind just forcing the water up there for days and days and days, and you have 15 to 20 inches of rain trying to exit out through the bayous there and into the intercoastal and then back into the ocean. It's not going to happen. So it could add on another couple of feet to that storm surge. So definitely people that live along any waterways that are attached to the ocean, I definitely keep an eye on this system, and definitely prepare your homes if you're within like 1 to 3 feet of the sea level or along the intercoastal waterway here, as you could be taking on some water in this case here with such a prolonged onshore wind flow event like this.
Hmm.
Definitely. Is there anything else you want to add on to this system, Derek, or did you want to talk about what we may be looking at in the future?
I think we should go talk about what we maybe look at. That's really weird. Our um thing has just popped up there.
Oh, that was because I had
Oh,
the
oh,
banner
interesting.
up like that. Um,
Did,
But this is what we're going to potentially be looking at in the future. We're going to pull up the models here. This is actually pretty good. We're going to have a look back up at 30,000 feet, and we're going to be looking up into New England. This is our first potential nor'easter of the year. That's been shown on a couple of model runs now, probably the past 3 or 4 reliable runs. And now that it's getting to be within a week of this potential system affecting New England, I think it's time to just put it in the back of everybody's minds. Not to fearmonger or anything, just potential of it. And it definitely, to the meteorologist's eye, looks incredibly interesting um, on the upper air maps as of right now. Definitely something that needs to be watched here, but certainly nothing to be scared of at this point in time. But let's have a look at what needs to happen in order for the system to actually work here.
mm-hmm.
And then we can watch the trends of the models, so then we can determine if this is an actual threat to New England or not. So what we're going to be looking at here is a Miller A type system. What is that? That is when a piece of energy from Alberta, otherwise known as an Alberta clipper,
Nerd. Sorry.
rushes down out of out of Alberta here on this strong jet and interacts with the weaker subtropical jet here. And when those merge, as shown right here, uh, two these two jets are merging here, you generally get a transfer of energy to the coastline as you get the development of the nor'easter. And once you get that merge of energy, you generally get a rapid intensification of that low level jet on the southern end of the system here. We're going to break this down a little bit later if we actually need to talk about this. I'm kind of just rushing through right now. But you generally see a rapid intensification of this low, rapid deepening, and rapidly increasing winds. And as long as we can get a blocking high out over, we call it a Greenland block, out in the middle of the Atlantic Ocean there, we'll get this pattern set up, and this storm will sit in the bay here, in the Gulf of Maine, and intensify and rip wind, strong wind into down east Maine, also the Cape, those sorts of areas. And with a setup like this, you could also potentially be wrapping in enough cold air to be talking about snow up in especially interior New England, for the mountains at least at this point. But this is completely tentative right now, depending on if we can get that Greenland block to develop over the Atlantic and if we can get these two jets to merge. If we can get those two things to happen, we'll keep you updated. And if we do need to do any additional updates on this, we will let you know as soon as we know the storm is going to be meaning business up in the New England area, since we do love forecasting up there, since we're both New England boys, you know. But
And
anything
also,
else
you know
you
what
want to add
nor'easters
after that?
mean? My Derek's favorite meteorological phenomenon is going to be happening up in New England, possibly. So, unfortunately, I will not be able to be chasing this to experience it, but we will get back to that if it looks like that there is a chance for it to happen. Let's build some suspense here. Dun,
Yeah,
dun,
yeah,
dun, 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 dun.
absolutely. All right, everybody. Well, you guys have a great night, and we will be back live with you, potentially with some interesting forecast challenges and a cat. There's the cat. um, there's the cat. But other than that, we may have an interesting forecast challenge for you guys coming up in the next video. So stay tuned for that, and we are out.